Alright, moving on to the back side of the horizontal and vertical shifts, translations. For each of these questions here, you have to know basically originally what either the y-intercept is or the x-intercept, and then you have to do the shift to figure out what the new one is. So this here, that's the equation of a line. It's y equals mx plus b. Well, this number in front of x, that's the slope, but the number on the end, that's the y-intercept. So if this line is just normally graphed, it'd have a y-intercept of 2. And here you need to shift it vertically 6 units. So the new y-intercept is your old y-intercept plus 6. And that's going to give you the magical number of 8. This next guy, that's the graph of a exponential graph. And normally exponential graphs look like this, and they cross at the point 0, 1. So they would normally have a y-intercept of 1. But this one already has plus 3 on it, so its new y-intercept would actually be at 0, 4. But you need to translate this one vertically negative 4 units, and so you take your current y-intercept of 4 and you subtract the 4 there to get a new y-intercept of 0. So this graph would kind of be down here and going up like that. Moving on to 9, this is an equation of a line, just y equals 2x, which is a line that goes through the origin, has a x-intercept of 0. And we need to translate horizontally negative 5 units. Well, if you take 0 and you subtract 5 from it, you're going to get negative 5 for your new x-intercept. And then if you look at this next one, it is the line of negative 2x minus 6. And you need to translate it horizontally plus 3 units. Well, something that is good to do is graph the line first to figure out how it's being translated to figure out where the original x-intercept is, because without that knowledge it makes it really hard to know where the new one's going to be. Well, this line starts at a y-intercept of negative 6 and has a slope of negative 2. So if I go up to left 1, I can put new points up to left 1, up to left 1. This line is looking like it's crossing right there at a x-intercept of negative 3. So that's the point negative 3, 0. And so if you want to get the new x-intercept, add 3 to your negative 3 there, and you're going to get an x-intercept of 0. Moving on to the next ones, on all these next two, you have to use this table of values to do your shifts. So when you're completing this table here, you gotta take the function values and subtract 3. So we're gonna take all these function values, subtract 3, put them here, but these x values aren't changing at all. So we're gonna just write them all down again. Let's see, that one's gonna be 3. And we got 5 there. So taking all these and subtracting 3 like it says right here, top one's going to be 0, next one's going to be 3, next one's going to be negative 5, next one would be negative 2, next one would be negative 5, next one would be 3, and the last one would be 0. And moving on to the next one, we have to take all the x values and we have to add 3 to them. So notice the inside, the x values are getting, all the x values are going to be 3 more, but the function values aren't going to change. So these will be the same as the original over here, but the x values are going to be 3 more. Here are my x values. I got negative 5, negative 3, and 1, 0, 1, 3, 5. So if I just copy those over, add 3 to all of them, I'll get negative 2, 0, 2, 3, I believe. Yeah, adding 3 to all of those. So negative 5 plus 3, negative 3 plus 3, negative 1 plus 3, 0 plus 3. And then I have to take 1 plus 3, 3 plus 3, and 5 plus 3. And I got those x values there. And my function values I'm just going to copy over to get what they are. So I got 3, 6, negative 2, 1, negative 2, 6, and my last one was 3. And so those tables are now done. These last two, it gives you a graph of a function, but the equation, it's got a missing number that we don't know quite yet. And so what we have to do is imagine what the line would look like without the k part. So if it was just f of x equals 3x, it would look like this, right? It's got a slope of 3, crosses at the origin. Well, this new line is just this one shifted up 3, and so this here would have to say plus 3 because it's a line up 3 units, and so k would have to equal 3. On this next one, a line that looks like just y equals 1/2 x would look like this guy. And it crosses at the origin, it's got a slope of 1/2, looks like that. Well, in order to get from this guy to this line, you would have to go down 3 units, and so k here would have to equal negative 3, because you have to subtract 3 from your function to go down 3 units. And that's it for that assignment.